Really doing that?
Yes, go.
Dropouts. A statistics professor has observed that for several years, about 13% of the students who initially enroll in his introductory statistics course withdraw before the end of the semester. A salesman suggests that he try a statistics software package that gets students more involved with computers, predicting that it will cut the dropout rate. The software is expensive, and the salesman offers to let the professor use it for a semester to see if the dropout rate goes down significantly. The professor will have to pay for the software only if he chooses to continue using it. Alright guys, so before we do anything else, you probably want to write out the null and alternative hypotheses. I'm going to start with the alternative hypothesis because this is the claim in this case. So, P is less than 0.13, and this is our claim. Now remember, this is written like this because the claim was that the software will allow the dropout rate to go down, hence why the alternative hypothesis is the claim. From that, we can get our null hypothesis, which would be that P is greater than or equal to 0.13, which would prove that the software does not work. Now, the first question is whether or not this is a one-tailed or a two-tailed test. And remember, for figuring out whether it's a one-tailed or a two-tailed test, you always look at the null hypothesis. And as this has a greater than sign, it is obviously a one-tailed test. Next, the question asks about type 1 and type 2 errors. To refresh your guys' memory, a type 1 error would occur if the null hypothesis is true, but we reject it. So in this case, it would be that the software doesn't work, but the professor falsely buys it thinking that it does work because he would have rejected the null hypothesis. Now, a type 2 error, if you guys remember, would be if the null hypothesis is false, but we fail to reject it. In this scenario, a type 2 error would occur if the software really does work, but the professor thinks that it's jank. So, what that would mean is that this hypothesis is not true, but the professor would accept it anyways. Now, the last question deals with the power of the test. So, the power of the test is, if you guys remember, the probability that the type 2 error is not going to happen, or in other words, if the null hypothesis is false and we reject it, otherwise known as 1 minus beta. To put this problem into the terms of the situation, it would be if the null hypothesis was true, so that would be if the null hypothesis is false. If the null hypothesis is false, but we reject it. So, hold on one second. So this would be...
I'll edit it out. Keep going.
Okay. I'm just going to come back here.
Okay.
So the power of the test in this scenario would be the probability that the software does work and the professor does buy it. Alright guys, so there's problem number 19.